What's up, everyone? This is Josh from Keep It Techie, back again with another video. And today I'm really excited to share something new that Canonical, the folks behind Ubuntu, have been working on. It's called MicroCloud, and it's a lightweight open source cloud solution built for Homelabs, edge setups, and even DIY infrastructure projects. Now, before I get into it, this video is sponsored by Canonical. Big thanks to them for supporting the channel. You know me though, I'll always give you my honest perspective. You'll also find a link to Canonical's YouTube channel down in the description if you want to dive even deeper into MicroCloud and see what else they're doing. And of course, if you enjoy videos about Linux, open source software, and Homelabs, go ahead and smash that like button right now. It really helps the channel and lets me know you want me to keep bringing you this type of content. So let's get to it. So why should you even care about MicroCloud? Let's be honest. If you've ever thought about running your own private cloud, you probably looked at options like OpenStack or Kubernetes. And while those are powerful, they're also either too heavy or too complex to really make sense for smaller labs or edge environments. Now, MicroCloud kind of fills that gap. It's designed to be production grade, but lightweight. You can spin up a cluster in just minutes with a single command. It also supports both KVM virtual machines and LXC containers, and it's secure by default. That means we get enterprise level features in a Homelab friendly package. And the part I really like, this isn't just a toy project. Canonical designed MicroCloud with edge computing and distributed environments in mind. The exact same technology you test in your home lab could be deployed in a retail store, or maybe a bank branch, or a small office cluster. That makes what you're learning here directly transferable to the real world. Now, for me, that's huge because my home lab is my test bed. It's where I break things, learn, and figure out what works before I ever think about running it in production. And I know a lot of you watching are in the same situation. Of course, I'm running Proxmox on an older Xeon box. It's got 6 cores and about 62 gigs of RAM. And let me be real with you, it's already maxed out. Like CPU runs around 30% most of the time. Memory is at 80% used, and I'm constantly juggling what I can keep running. But that's just home lab life, right? We basically work with what we've got. All right, so before we get started, I want to show you guys that I have 3 nodes set up for MicroCloud. I wrote a script a long time ago, and I just modified it to create all the nodes for MicroCloud. And so they're all provisioned. They have everything they need in order to get MicroCloud set up. And I basically named them like Micronode 1, Micronode 2, Micronode 3, and gave them static IP addresses. Each one of them have 8 gigabits of memory. If you look at the requirements for production system, they say at least 32 gigabytes of memory, but I should be able to get away with 8 gigs on each one of the nodes. Like I said, we're just testing it out. I just want to walk you guys through, set it up. I won't put too much onto the cluster where we run into issues with the limited hardware that we have. So let's hop over to my virtual machine so we can connect to each one of these nodes and walk through step-by-step setting up MicroCloud. All right, so I have 3 terminals up and I'm connected to each one of the nodes. And I did this on purpose so you guys can see everything that'll happen on each one of the nodes while we set up the cluster. Now I'm SSHing to node 1 here, node 2 down here, and 3 over here. And the first thing you need to do is install MicroCloud on each one of the nodes. So let's like sudo snap install, and we need to get cloud install. So that's the package name, MicroCloud. Press enter. This will go through and install it on our node. And let's go down and copy this command so we could just go down and do it on each one of the other nodes because we need it installed there as well. So let's just give it a couple seconds to install on each node, and I'll be back in a sec. Now, once MicroCloud is installed on node 1, what we need to do is initialize our cluster. And the command is sudo microcloud and then init. Now, I suspect I may run into an error. Let's go down and run it right fast. I think we have to reset LXD. This is something that I've ran into a couple times, and yeah, as you can see, that error popped up. So error LXD is already initialized. So I have to go through and fix LXD, and a simple fix for it is to uninstall it, purge, remove any configuration files for LXD and then reinstall it. And one thing I have to do, and if I run into this error on node 1, I'm most likely going to run into it on node 2 and node 3. So I'll run each one of those commands to remove it, purge it, and get it back up and running on each one of the servers. All right, so I reset all of the nodes. So LXD has been reinstalled on each one of them. And so now let's try to initialize it, and it should work perfectly. All you have to do is type sudo MicroCloud and then init and press enter. And just to break down what's happening, this sets up the cluster and it makes node 1 the first member. And then once we get past a couple steps, it will ask us to add the other members to the node. And as you can see on this question, it says, do you want to set up more than one cluster member? And we're going to hit yes or enter. And that's the default. Now, right here, you will see a warning. It says MicroCeph and MicroOVN not found, and that's fine. We'll just ignore that for right now. I'll explain exactly what that is later on, but you could just continue on. Let's get the cluster set up. So what it'll do is bring up a dialog for us to add node 2 and node 3 by basically running some commands over there in order to get them added. And as you can see right here, it gives you the commands right here. So all you have to do is run MicroCloud join on each one of your nodes, and then you'll start seeing them populate down here. And I'll show you guys that once we get to it. So let's start with node 2, and let's run, you have to run sudo. So MicroCloud join, press enter, and this will find our node 1 that's trying to create the cluster. And then what it will do is ask for the passphrase. So all you have to do is copy this, make sure you don't get any spaces from the front or the rear, and then go down here and paste it in, paste in our passphrase and press enter, and you'll see it populate down here as a member of the cluster. Now we're not done yet. We need to go down and add node 2. So same command over here, the MicroCloud join and copy, and then let's type first and let's paste that in, and then press enter, and it'll find node 1, the cluster, and it'll ask for that passphrase again. And boom, you just paste in our passphrase, press enter, and you'll see it populate here on the initialization of the cluster. And then one thing I want to point out to you, each one of the nodes has a fingerprint, and you'll see those fingerprints. So basically it says verify the fingerprint for this server, which I'll just look at the last 3 characters, FAC. So as you can see, FAC is up there under micro node 2. It also has the IP address and all that stuff. And then if we go over here to node 3, you'll see 15F and 15F. So that is both of our nodes added to the cluster. Well, they're not really added, they're staged. So in order to add them, we have to select them. And if you go back over here on node 1 and you press up and down, you'll see that it navigates between each one of the nodes that are showing up there. In order to select them, we have to hit the space bar. So if you hit space, that will put the check mark, basically verifying that we want to add this server to the cluster. And then the same thing for node 3, you want to make sure you select all the nodes that you want to add to the cluster. And then as you can see down here, the instructions, all you have to do is hit enter to confirm. So let's go down, hit enter, and the initialization will finish up. And I wanted to keep all of these running, or that's the purpose of bringing them all up, so you can see exactly what happens when it adds all the nodes to the cluster. And now our MicroCloud is ready. And as you can see, it added each one of our nodes to the cluster. Local MicroCloud is ready. Local LXD is ready. And it's also ready on all the other nodes. Quick side note, if you want to add more nodes later, let's say you want to make it a 4-node cluster, then what you want to do is go back to your node 1 and type, instead of initialize, you want to type add. And this will allow you to add another node to the cluster. And it will go through the same process starting from here. Well, it'll give you the instructions to run on the new node that you want to add. So MicroCloud join. So you type sudo MicroCloud join. And then it will generate a new passphrase for the new node. So all you have to do is paste that passphrase in there. And then it will add that 4th node or 5th node to the cluster. And also you want to verify your fingerprints and all that stuff, just like what we did when we first initialized. So just wanted to give you that information in case you want to expand your cluster. Now that our cluster is built, I wanted to show you guys how to check the statuses and just look at a little information about the cluster's health and any warnings that may pop up. So right here on node 1, let's just run sudo MicroCloud and then status and press enter, and it'll give us information about all the nodes in the cluster. Now you'll notice a warning here about MicroCeph and MicroOVN, and don't you remember we saw that during the initialization? And these are optional add-ons. And just to explain them to you, MicroCeph is a lightweight distribution storage system giving you replicated and fault-tolerant storage access across all your nodes in the cluster. And MicroOVN, it basically handles advanced networking, lets you create overlay networks and cloud-style routing. And for a simple Homelab demo, or what you probably will set up in your Homelab as well, we don't need either of those. So I can safely ignore these warnings and stick with the defaults. Now, let's say you're in a production environment or at a business, then you definitely want to take advantage of those two tools by getting them installed. All right, and let me also show you a couple more commands. So let's type sudo MicroCloud, and then we can type service and then list. And we press enter there, and it'll just give you a little bit more information about the cluster. This breaks down how the cluster is set up. So this is under LXD. It says micronodes. This is the IP addresses, the roles. So as you can see, micronode 1 is our database leader, and it houses the database as well there. It's online. That's the status. And then also when it comes to clustering, each node in the cluster has a vote in order to remove nodes or shut down the cluster and all that stuff or whatever. So that's a standard cluster setup, and I just wanted to point that out to you, but that just gives you a little bit more information about the MicroCloud setup. Now, let me run another command just to give you guys some more information. So sudo lxc cluster list and press enter, and this will give you more information about each node in a cluster. And so if you want to see the roles, the architecture, the failure domain, description, state, and any messages, then you want to run that lxc cluster list command. Now, next we need storage. In a cluster, I need to stage a pool on each node and then commit it cluster wide. And I'll show you guys how to quickly do that. I basically wrote a for loop that'll run through each one of the nodes and basically stage the storage to it. And then I'll show you guys how to commit it cluster wide. So like I said, this is a for loop. It's basically going to run through each one of our nodes. So node 1, node 2, node 3. So for each, and then it's going to run this command right here. And let me just run it, and I'll show you guys the command that I'm talking about. So as you can see, storage pool, local pending on each one of these members. So that means it's staged. And essentially what it's doing is staging it using this command. It's going to create our storage. It's going to call it local and then dir. And then this is for each one of the targets to stage it. Now, in order to commit it, it's basically just the beginning of this command right here. So instead of a specific target, then you want to specify the full cluster by not putting a target. So essentially, let's just paste that in and then enter. And this will commit it to our cluster wide. Now, in order to verify it, we could type sudo lxc storage, and then we can specify our local storage that we set up. That's the name of it. So let's press enter. That'll give you the information about the local storage. And as you can see, it's located on each one of the nodes. It's shared storage. So we're good to go. Now, one thing I want to check is the default profile for the root. This is something you need to just verify. And what you can do is type lxc and then profile and then show default and press enter. And this will verify if our drives are there. And it's not there. All we see is our networking device. So run a quick command. I already have it written out. This is something I've ran into in the past. So I have a command written out, but essentially it's going to add our storage to the default profile. So let's go down and press enter. And then as you can see, device roots added to our profile. And you can verify by basically running the command before that shows our defaults, and you'll see our dis right there. So it says roots and then a path to it, local, and this. And this basically ensures that any new workload knows where to store its data. That's essentially the purpose of adding it to our profile. And actually, it's one more command I need to run, and this is to make sure I set it. And I already had a command written out. I'll kind of walk you guys through it, but it's basically setting the default root pool. When you run it up here, this is just adding the defaults, but this will actually set it. So any new container or any new virtual machine will know where to store it. So let's press enter. We're good to go there. Now for networking, MicroCloud automatically creates a cluster-wide fan bridge called LXD fan 0. And this gives my workloads NAT and allow them to communicate across nodes out of the box. And so we can check this by using a couple commands. Let's type that in. So sudo lxc network and then list and press. This will list out all of our networks. And if you want to set up your own network, you're more than welcome to. There's a couple of LXC commands you have to learn in order to do that. But I recommend you just roll with the defaults until you get familiar with it. And that is one of the most difficult things I ran into early on while learning LXC and LXD was the networking portion of it. I ran into so many issues with that. Looks like they've ironed a lot of that out, and I'm glad they put a default in here so you can just quickly get your networking up and running. And maybe it was just the pains of trying to learn it when I was first learning it, just those growing pains and not really knowing what I'm doing. But now it seems like it's more streamlined and easier to get going. Now, you can also look at some of the information when it comes to the network. Like, let's say we want to look at LXD fan 0, or you have multiple networks. I just want to show you these commands so you can at least know how to look at it. So let's go LXD fan and then 0. And the command is LXC network show, and this will show everything about that device, so to speak, or that bridge that we have set up. So kind of brings up the profile information as well. You can look at the subnets. That's the underlying subnet, and it's a bridge, you know, and the status is created and all that good stuff. So it just gives you more information about it. And as you can see, it's located across all nodes, which is perfect for how the cluster works. Now let's get to the fun part. This is probably the port you've been waiting for. Let's go down and clear and bring it up to the top. But let's show you how to launch a container. And all you have to do is type sudo lxc launch, and then you want to specify an image. So Ubuntu, we'll just roll with that, and then 24.04. And you want to name your container. So we'll just name it C1 for container 1 and press enter. And I'll go through and launch our container. And just so you guys know, you won't be able to do this unless you set up storage. So you have to go through that storage process. You can't just skip ahead. You have to have that storage set up. That way, when you launch it, it knows where to store the data. So that's done. It created our container. And let me just run through a couple commands. So sudo lxc list. This will list out any of the containers you have running on your system or virtual machines. And then also, let's say you want to look at information about that specific container. You can type sudo lxc and then info C1, or the name of our container, or virtual machine. It's the exact same thing when it comes to virtual machines. Those same commands will work. And this gives you information about the container, more detailed information, like for instance, the process ID, the current location of the container, the architecture, the amount of processes, CPU usage, and memory, just basic information about the container. Now, let me show you guys how to connect to it, and I'll just clear, but let's type sudo lxc exec and C1 and then dash. Let's use bash and press enter, and this will log us into it. As you can see, we're in that container. So let's just run just a couple commands. So who am I? We are root. Let's see, lsb underscore release. And let's do -a just to check it out. So we got Ubuntu 24.04.03 LTS and codename Noble. So that is our container. It's up and running. Now you can install applications on here. You can install like Nginx or set up a web server, you know, or test out an application, whatever you want for this container. But let's go down and exit out, and let me walk you guys through setting up a virtual machine. Now, I have a configuration file already written out that I want to create. So I'm gonna just use the cat command to create that configuration file, and I'll open it up so you guys can see what's in our configuration file. So it's stored in our home directory. I'm gonna just hit ls and then cat that out. So cloud.conf, press enter. And basically what this is, a configuration file that we will inject into our virtual machines. That way we can log into them. Because typically what you would do is set up SSH keys. I wanted to create an account, just show you guys something a little different, but you still have to inject those keys the exact same way, injecting this username and password. And that's mainly because I don't have any SSH keys on any of these nodes. So that was the simplest way for me to set up our virtual machines. Now, let me run through how to actually start a virtual machine. And basically all you have to do is type sudo lxc, and then what we want to do is grab a image. So we're going to go with Ubuntu and then port 2404, and then we want to name our virtual machine. So let's just do VM1, and then let's type --VM, and then now we have to specify our target node. So let's just go to another line. That way I can space it out so you guys can see exactly what we're doing. So we have to put in another option, which is targets. And then we want to specify the target. So we want to create this on node 1. So you want to specify the node you want to bring this up on, or at least create it on. And let's create another line because you want to set limits on your virtual machine, because if you give it everything on your system, like these nodes have like 8 gigs of memory on each one of them. So, and like I said, that's not really enough for a production environment, but it's enough for what we're doing here. So you want to set limits on it. And the way you do that is you type -C and you can specify those limits. So let's type limits, and then let's specify our CPU. Let's just make sure it doesn't use more than 2 CPUs. And then let's create another line, and we can type -C, and then we want to limit our RAM. So we're going to specify our memory to only go up to 4 gigabytes. So you have to type it in right. So it's capital G and then lowercase I and then capital B. That's gigabytes right there. And then that's pretty much it for the command. So let's press enter and it will create our virtual machine. Now, like I said, virtual machines, they use up a lot more resources on your server. So it'll take a little time to boot up, and it also doesn't start right up like our containers. We actually have to start it. So I'm gonna be back when it creates the virtual machine, and then I'll run through how to actually start that virtual machine and log into it. All right, so our virtual machine is created, and as you can see, we didn't run into any errors. Now, like I said, the virtual machine does not start. And you remember that configuration file that we created in our home directory, the cloud.conf? Well, it's time to now inject that into our virtual machine before we start it up. That way we can actually log into it. So let's type sudo lxc and then config, and then we want to set our config for VM1. And what this is for is the user data. So we need to type cloud-init and then .user-data. And let's type a dash in there, and then we need to do the left arrow cloud.conf. And this will inject it, or basically set it to our virtual machine as this is the user data for this virtual machine. So let's go down and press enter. That will add that. And now we can actually start up our virtual machine. So let's go sudo lxc start VM1. There we go. So that will start our virtual machine. So if we type sudo lxc list and press enter, we'll see our virtual machine is up and running, as well as our other container and all that good stuff. And then also we can look at the information just like we did in the past. We can type sudo lxc and then info for VM1 and press enter. And this will give you all the information we set for our virtual machine, like our limits. But let's say you need to find out the IP address. So there we go. So this is the IP address. And that's why I said it was super important, or I'm super happy that they set up network so we don't have to worry about it. Now, let me show you guys how to connect to our virtual machine. So let's clear again. And the way you do it is running the console command. So sudo lxc and then console, and then specify our virtual machine. So let's press enter there, and it'll give you instructions how to disconnect from the console. Make sure you take note of that. It's Control+A and then press the letter Q. Now that's going to disappear in a second once it starts loading into the console. So just make sure you remember that, because if you type exit once you're in the console, it will just drop you back to the virtual machine, to the login screen, like on a server that you're logged into or that you connected to. But let's give it a second. It should be up in a second. Now, while I wait for the console to connect, let me clear the screen on all of our other nodes, because I want to show you guys something in a couple minutes. All right, so as you can see, it's booting up. It only took a couple seconds. I just paused the video and then it popped right up and logged into the console. So let's go down and log into our virtual machine. So all we have to do is type Josh or whatever username you created, and then I just put KIT as the password, and you can log in it just like any other system or Ubuntu system that you have set up, like a server or something like that. And let's press enter. So yeah, we're logged in. You can run who am I again, and we're Josh. And then let's just run something like lsb release and -a, press enter, and boom, you'll see the system that we're connected to. And so that's kind of all I wanted to show you there. With the VM, you can install whatever applications you want. So we can just exit out. And like I said, you want to make sure you remember those commands that I told you. See, as you can see, I hit exit, it logged out of it, but I'm still connected via a TTY. And the way to fully connect from the console, you have to hit Control-A and then Q, and that'll get us out of the console for that virtual machine. Now, I'm going to show you guys how to move our workloads between the nodes within the cluster. So like our container or our VM, we can move it to a different node. Let me show you guys how to do it. With the containers, you have to stop the containers. Now, there is another application you can install that allows you to do it live, but I'm gonna show you guys the basic way. So we can run sudo lxc, and then we could stop our container. So C1, press enter, that'll stop our container. And then we can run that sudo lxc list, and just to verify that it's stopped. And as you can see, our container is stopped. Now we can move our container over to a different node, and the command to simply do that is sudo lxc and then move. And then what we want to move is our container. So you have to type in that name, and then we have to specify target. So dash targets, and then let's move this to micro dash node dash 2 and press enter, and this will move it over. It will take a little time because it has to transfer all of the data over and then bring it up on that node. And we'll verify it. I'll just pause for a second and come back when it finishes. But this is great for, let's say you need to do some maintenance on node 1. You have to run some upgrades to it or something to that effect. You can move your services over so they're not interrupted until it comes back up, or at least you bring that node 1 back up, and then you can move it all back. And boom, as you can see, we have transferred it. And just to verify it, we can run sudo lxc list, and we can verify where that container is up. And as you can see, it's on micro node 2 like we specified. And we can start that container back up. So let's just press the up arrow and start our container, and it'll start running on our other node. So let's check it out. And boom, you'll see it running over on node 2. And let's say you want to move the VM as well. We can do that by just running the same command. We just need to specify where we want to send it. So let's just press the up arrow, find that command. So what we want to do is move VM1, and let's move it to a different target. Let's do 3. So sudo lxc move VM1, and we want to move it to our micronode 3. So this will take a little time because, like I said, it uses all the resources. This is a full-blown virtual machine. So I'll be back when it finishes. All right, so it finished transferring, and as you can see, we didn't get any errors, but it is transferred over there now. And we can verify this by just typing our sudo lxc list, and this will show you where it's located. So VM1 is now located on micronode 3. And the cool part about it, the VMs, they will start right back up. Now we had to specify the stop over for the containers, but VMs, they will move over and then just start back up if it's in a running state. Now with containers, live migrations, they require a package called CRIU. And if you don't have that package, you have to stop, move, and then start. I know I cleared these other terminals just to show you some information, but a lot of these commands you can run specifically from any of the nodes that are there. So you can run your status over here. You can run your sudo lxc list on a different node. Like I said, all this stuff is synchronized between all the nodes in the cluster. So you can pull up all the information on any of the nodes. Now, finally, snapshots make testing safe. And we can run snapshots on VMs or containers. And basically, if anything goes wrong with your VM or container while you're testing it, you can restore it instantly. And let me show you guys how to quickly do that. It's a couple of commands. So all you have to do is type sudo lxc snapshot. And let's take a snapshot of the VM. So let's go VM1, and let's just create a snap called snap1. And press enter, and we'll wait for that snapshot to be created. And it doesn't matter where the VM is running at, it will take a snapshot. Like for instance, our virtual machine is actually running on node 3, but it'll create that snapshot nonetheless. As you can see, I ran out of space. These nodes are not that huge, so I don't have all the space in order to create that snapshot. So let's just do our container. So let's remove the VM and let's just do the container, but it's the exact same way for our virtual machines. And let's just go down and run it for our container. And boom, super simple. So we got a snapshot of our container 1. And just to verify that, we can run sudo lxc and then info of our C1, our container 1, and then we can look at our log. So let's type show dash log and press enter. And you can see the snapshot that we have right there under our container. And it would show the same way if our VM completed, but it didn't because we ran out of space. And just to show you guys how to restore it, it's pretty much the exact same command. Let's go back up to snapshot. Instead of snapshot, all you have to do is specify restore instead of snapshot. So let's type that in and press enter, and that'll restore from a snapshot, and boom. And that's the demo. We initialize a MicroCloud cluster, explain the operational CEP and OVN services, set up storage, check networking, launch both containers and VMs, migrated workloads across the nodes, and finish with snapshots and restores. Now, all of this runs right in my Homelab, but it's the same technology, Canonical, designed for edge and production environments. So where does MicroCloud make sense? In a Homelab, it's perfect for learning clustering, high availability, and cloud native workflows. In a small office, you could set up 3 small servers, run apps privately, and avoid public cloud costs. Now, for developers, you can spin up disposable environments quickly, test applications, and tear them down without burning through AWS credit. And at the edge, think retail stores, telcos or bank branches. It scales down enough to run on small form factor devices, but still gives you high availability clustering. All right, now one of the things I like to do is talk about the pros and cons of an application that I show you guys. And let's start with the pros. For one, it's super lightweight and easy to install. As you can see, it was basically 2 commands to set everything up. And then you had to run a command on the remaining nodes to get them added to the cluster, which is super simple. So that's a total of 4, and it all depends on the size of your cluster. So if you have a 4-node cluster, then yeah, you have to add 1 more command to it. But one thing I really like about it is supports both VMs and containers. Also, another pro is it's secure by default and clustering 100% built in. Also, it's backed by Canonical with LTS releases, which is that long-term support that we all love. Now, some of the cons, it's still new, so the community is smaller compared to Kubernetes. Now, the docs are good, but not yet as deep as older projects. And then also your Homelab hardware will set limits quickly because, as you can see on my system, more RAM means more fun. But overall though, I'm impressed. For something that's just getting started, MicroCloud already feels solid. And the fact that Canonical is behind it gives me confidence it's going to keep improving. So that's Canonical MicroCloud, a production grade open source cloud you can actually install and run at home. Big thanks again to Canonical for sponsoring this video. Make sure to check out their YouTube channel. I've dropped the link down in the description of the video for more tutorials and content around MicroCloud. And if you enjoyed this walkthrough, go down and hit that like button, subscribe if you haven't already, and let me know in the comments if you'd try running MicroCloud in your Homelab. Thanks for watching, and as always, keep it techy. Yo, what's up, y'all? Listen, if you've been sitting there thinking about making a move, let me tell you, tech is where it's at. I don't care where you're coming from, whether you've got a degree, a GED, or just pure hustle. There's room for you in this game. You see, tech is more than just keyboards and code. It's solving problems, creating opportunities, and building the future. You already have what it takes because tech doesn't care where you start. It cares where you're willing to go. You can teach yourself Linux, learn Python, break into cybersecurity, or even launch your own app. And the resources are out here for free. And yes, you heard me, free. Now, yeah, it's gonna take effort. You'll have to grind, but think about this. The time is gonna pass anyway. So why not invest it in a skill that'll change your life? I mean, tech doesn't just pay the bills, it opens doors to freedom, stability, and generational wealth. So stop doubting yourself, start small, stay consistent, and keep building. Because this isn't just a career, it's a movement. And guess what? You belong here. So let's get it, because the future is yours to build. Keep it techy.